Okay, 11.1, area of triangles and parallelograms. Let's say we got a square. Notice our area postulate all depends upon the square because we say things like square centimeters and square inches. That's basically saying we take some kind of figure, be it a parallelogram, and we break it up into its individual square components. That's what we say. So we got to start somewhere when finding the area. We're going to call this our square postulate. Let me change colors. Square postulate. Excuse me, square area postulate. This is basically our starting point for finding all other areas, like the area of a rectangle. Area of a rectangle is the area of the rectangle, the product of its base and its height. So we have some base and height, but note that it's not really dependent upon which one comes first or so forth. And this is something you've seen from middle school. Base times height, or length times width. Area of parallelogram is a little bit trickier to show, but it's the same thing. We have a base and we have a height. And I'm going to move, that height over there. So height is this value right here. Now, this is directly correlated to a rectangle. Remember that the sides of a parallelogram are parallel, obviously. And if I take this triangle, I think it'll help establish something. Let's say we have this triangle here, and I chop it off and move it to this side over here. Then you would see that this is completing the rectangle. So this triangle here, if it's a right triangle, because it has to be, because the height has to be perpendicular to the base, then it's the same as this triangle, and it goes over here and becomes the same as the rectangle. So the area of a parallelogram is the same deal, base times height. But let's say we were to take a parallelogram and chop it in half. Notice if we did that, let me undo that. We took a parallelogram and chopped it in half. You would have two triangles. So a triangle must be some type of halving of a parallelogram. In fact, that might help you see the next deal. Let's say we have a triangle. If I take this triangle and flip it about itself so I get the other side, you would get something like this. In fact, I'm going to go work that out. Let's move this over. I'm going to shrink it down a little bit. And let's copy it. And I'm going to flip. There we go. We'll get it straight in a second. So if I take this triangle and I flip it about this line, kind of tricky to do in a notebook, but you got the idea. Then the triangle is just half a rectangle, or half a parallelogram. And a parallelogram is just a sliding over of a rectangle. So the area of a triangle, therefore, is base times height divided by 2. Awesome. Let's dive into some problems. Like, let's say we have this. The directions are for you to find the area of parallelogram RSTU. Now we have 25 and 35, but the only thing that's going to help us directly is this 35 here. So this 25 doesn't help us here, but notice that if this segment extends, it's perpendicular, and this here is the height of the parallelogram. So if the area of the parallelogram is base times height, then this is just 20 times 35. That multiplied out is 700. Now this is square units. If you're not given any value, you're going to have to say units squared. Let's say I've asked to find the area of the parallelogram. Parallelogram is a little bit trickier to see, but it's ABCD. Same deal, you just have to reason it out. Notice that this is one of the bases, and this here is one of the bases. The base over there, and this is the height between the two parallel sides. Remember, the area of a parallelogram is just the base times the height. 16 times 4. 16 times 4 is 40 plus 24, which is 64. And once again, if we do not have any units, we're going to have to write units squared. Awesome. Let's say we got to find the perimeter and the area of this figure, given that 21 is the total distance here. Now, if these are right triangles, both of these, this one and this one, then we can find the base. We already have the base. And we already have all we need to find the values. So, the perimeter is just adding all these up, and the area is the base times the height divided by 2. In this particular case, I'm not really wanting to make a mistake in a video, so I'm going to check my work with a calculator. Notice 17 plus 10 plus 21 is 48. And 8 times 21 divided by 2 is 84. So the perimeter is 48. And we do not have a unit, so we just have to say units. And 84 units squared for the area. Let's say we need to find the perimeter and the area of this figure, this parallelogram. And remember, the opposite sides of a parallelogram are congruent. Therefore, the perimeter is just simply 50 plus 50, which is 100 units. And the area is the base times the height divided by 2. It's 30 times 17 divided by 2. I get 255. You might be asked to find the perimeter and the area of a right triangle without being given one of the bases. Notice this is the right triangle. We have 5 and 13. That means this must be 12 by Pythagorean triples. So the perimeter is just the 5 plus the 12 plus the 13. I get 30. The area is just the 5 times the 12 divided by 2. So 5 times 12 divided by 2 is 30 as well. Remember to label your units. Alright, let's do a little bit more of a tricky one. Let's say the base of a triangle is twice its height. So if I have some height here, if I multiply it by 2, I get the base. The area of the triangle, height times 2 times the height, is equal to 36. By the way, this needs to be divided by 2 because it's a triangle. Find the base and the height. That means I just need to solve for h. Notice the 2's are going to cancel here, and we've got h squared is equal to 36. Algebraically, this is plus or minus 6, but geometrically, we only allow positive distances. So we just have the 6. H is equal to 6, and the base is equal to 2 times that, which is 12. And that's it for the video.